Hello students of class 9th, this is your second chapter. Is matter around us is pure? I have already sent one video before, but this is note pattern video, so please note down this with your explanation. So here classification of matter given. On the basis of physical state, matter is classified into three main types. They are solid, liquids and gases. On the basis of chemical composition, matter is classified into two main types. They are pure substance and mixture. Pure substances are of two types. They are elements and compounds. Mixture are of two types. They are homogeneous mixture and heterogeneous mixture. In this way, matter is divided on the basis of chemical properties, pure substance and mixture. Further, pure substance divided into elements and compounds, and mixture is divided into homogeneous mixture and heterogeneous mixture. Now, in pure substances and mixture, what are their definition? What are the differences there? In this portion, I have explained. Pure substance is a substance which consists of a single type of substance. Element or compounds means single type of means their composition, the particles by which they are composed are having the same properties. Iron, copper, hydrogen, common salt, sugar, you cannot separate them easily in any physical method. Mixture is a substance which consists of two or more pure substances. Seawater, mineral, soil, air, that means their compositions can be separated any physical way. Differences between pure substance and mixture is: pure substance consists of a single type of substance. Students, you have any doubts that a sugar or common salt is compound which cannot consist single type of substances. Actually, the substance or the particles which are combined there in a certain ratio, so this is also called single type of substance. But mixture consists of two or more pure substances. That means you can easily separate them. Pure substance cannot be separated into other substances by physical method, as I explained you before, and mixture can be separated by any into their components by physical method. Pure substance has its own definite properties, but mixture shows the properties of its components. The substance, suppose you will add sugar into water and salt. The taste is different. If you add only sugar, the taste is different. If you add some more lemon juices there, the taste is different. That means property is different. So, mixture shows the properties of its components, but pure substance has its own definite properties. Always they have the same properties. For example, water having the same properties, although you have got it any the sources. Now, types of mixture. It is of two types, homogeneous and heterogeneous. Homogeneous mixture is a mixture which has a uniform composition. The particles of the mixture are not visible by the naked eye. The particles of the components are so tiny, they are mixed together and form a uniform, seen like one particles or one type of substance. Particles cannot be separated by filtration. Mixture is stable. That means the particles do not settle down or not separated easily. Path of beam of light is not visible in the mixture. That is one of the important property of the homogeneous mixture or true solution. I will later explain that. Mixture of sugar in water, mixture of salt in water, or mixture of copper sulfate in water are the example of this. And heterogeneous mixture, which has non-uniform composition. That means you can see easily or it is visible their components easily with our naked eye. The particles can be separated by filtration. Mixture is unstable. That means one of the components particle can be settled down on at the bottom of the other components. Path of beam of light is visible in the mixture. This is the important property. And example, salt and sand, sulfur and iron fillings, oil and water. Students, you can experiment or do this activity on your house easily, and you can see it or evident it by the experiment. Now, true solution. True solution means homogeneous mixture of two or more substances. That is called true solution. It has two parts, solvent and solutes. The larger amount of the component is called solvent, and the minimum amount or the lesser amount of the component is called solute. Students, here I want to explain that suppose you have one bucket of water and few spoon or cup of sugar there, and if you will mix it, a true solution is formed. Here water is larger amount, that water is solvent. But suppose you just opposite it, you take 1 cup of water and 1 kg of sugar in a big sack or in a packet. Then what you do? You will do to add water in the sugar, not sugar in the water, because the container is not so big. So at that time water is solute and sugar is solvent. True solution is a homogeneous mixture, as I have explained before. Particles cannot be seen by the naked eye. That means this is the property of homogeneous mixture. Cannot be separated by filtration. Particles do not settle down the solution, and light property, that means cannot scatter the particles or beam of light passing through it. So why true solution or particles are homogeneous? Because of its size. 10 to the power minus 9 meter diameter of the particle size approximately or minimum. So the particles cannot be easily seen. Colloidal solution is another example. Colloidal solution is heterogeneous mixture of two or more substances. Properties of colloidal solution is heterogeneous mixture. That means, and the properties of heterogeneous mixture you can explain here. Then another is suspension, is a heterogeneous mixture of two or more substances. It is also the, but what are the difference between suspension and colloidal? Let's see that. The size of the particles there. So in colloidal, particles of solute or one component which is lesser in amount partially dissolve in the solvent components. Here the term is different. Disperse phase and disperse medium. Instead of solute and solvent, we term disperse phase for solvent and dispersion medium like solute. So the size of the particles are between 10 to the power minus 4 to 10 to the power minus 7. And in suspension, the particle of the size more than the size of the particles in colloids. So here totally it is immiscible, settle down at the bottom of the solvent. In diagram it is explained. You can see and easily understand it. One of the important term is Tindal effect. As I explained here before many times, light scattered or beam do not show any property in true solution, and colloidal it shows the properties. So that effect, light property of the colloidal solution is called Tindal effect. When a beam of light is passed through a colloidal solution, the colloid particles scatter the beam of light and the path of light becomes visible in the solution. Do you understand it? Light when passes through the colloidal solution, you can see in the screen one figure is given, or you can see, or you have observed in your houses during daytime when sun rays comes through the window, one cone shaped structure is formed and particles can be moving there. This is called Tyndall effect of colloidal solution. Especially in colloidal solution, this is seen because particles are not visible, so it is scattered. Tyndall effect can be seen when light enters a room or can be seen in dense forest also. Okay. The same diagram is largely viewed here. You can see. Now, other term is saturated solution. Is a solution which cannot dissolve any more of a solute at a given temperature. Suppose students, you have same solution, sugar and water. You will add 1 cup of water, 2 or 3 spoon easily, but after 3 spoon it is not easy to mix more spoon of water, sugar in water. Why? Because saturation comes there, and after 4th spoon of sugar it is immiscible when you add more 5th number of spoon of sugar there. So at the certain temperature, the solubility of the solute in a solvent which is easily solute, not more solute is dissolved there, that is called saturated solution. So solubility means what? Amount of solute present in a saturated solution of the substance. Example is same. 3 spoon easily dissolved, 4th is very hardly dissolved, so 4th is the 4th spoon of sugar in 1 cup of water is solubility. It is always in a physical unit used there or defined there. Now unsaturated solution, the same, the opposite, means what? When you are able to add more solute in the solution, that is called unsaturated. So for the preparation of saturated solution, following activities can be done. Take 50 ml of water into 2 beaker, add salt in 1 beaker. Here the next another solute which is easily dissolved in water is salt. So instead of sugar you can add salt, or you can add sugar, and solubility is different, substances are different, you can observe through it. Now to calculate concentration of solution, the formula is amount of solute upon amount of solvent, or sometimes amount of solute upon total amount of solution is also used there, or mass on the basis of mass, percentage mass of solute upon mass of solution into 100, or mass volume percentage relation is mass of solute upon volume of solution into 100. That means when both are in the solid state, you will take mass of solute and solution, but whenever one of the solute is in the solid state but solution is formed in the solution or liquid state, you will use volume for the solution and mass for the solute multiplied with 100. So students, up to this, the first video, you will note down it by thoroughly read or watch the video. Thank you.